Good morning, students. In this session, we'll discuss about relation between E bar and H bar. And to find the relation between E bar and H bar, we need Maxwell's equation for free space. That's what I already discussed in our previous discussions. That is, we know that the Maxwell's equations for free space, Maxwell equation for free space, one is del dot d bar equal to 0, and the second one is del cross E bar equal to minus dou B bar by dou T. Third one, del cross H bar equal to dou D bar by dou T. Del dot B bar equal to 0. These are the four Maxwell equations for free space. Now, just consider equation 3. Consider equation 3. Now I'm writing equation 3 here. Del cross H bar equal to dou D bar by dou T. Now I'm substituting a small substitution, D bar. D bar can be written as epsilon naught E bar. Then it will become del cross H bar equal to dou by dou T into epsilon naught E bar. That is del cross H bar equal to epsilon naught into dou E bar by dou T. So E bar by dou T. Here, since D bar equal to epsilon naught E bar. Now I am making cross product for this expression. Now to perform cross product this expression, now H bar is a vector. Then those vector can be expressed in 3D coordinate point of view as H bar is equal to Hx plus Hy plus Hz. Similarly, E bar can be expressed as Ex plus Ey plus Ez. Those two can be expressed like that. And we have already del as dou by dou x, dou by dou y, dou by dou z. And with this existence, I am making cross product for those existence. Now, by performing cross product here, first the value of del is Ax, Ay, Az are the coordinates. And here del value can be dou by dou x, dou by dou y, dou by dou z. And here the next term is H bar, that is H bar value Hx, Hy, Hz equal to epsilon naught into this E bar. E bar can be expanded like this, that is dou Ex by dou T into Ax plus dou Ey by dou T into Ay plus dou Ez by dou T into Az. This is the expression. This is the term. Now, just simply I am assuming here when the wave is traveling along x direction, that is, the wave is traveling along x direction. When the wave is in x direction, then the values of Ex equal to 0, Hx equal to 0, dou by dou y equal to 0, and dou by dou z equal to 0. Now I am substituting all these values in above equation. Substitute all these values in above equation by substituting that ax as usual, ax, ay, az, and dou by dou x value as usual, dou by dou x, dou y value 0, dou by dou z value 0, hx value 0, hy value is existed, hz value is existed, equal to epsilon naught into, here the ex value again, ex value 0, so x term may be, this x term may be eliminated. Then I'm having here dou ey by dou t into ay plus dou ez by dou t into az. By substituting all those values, wording like this. And look at here, in these all the parameters I'm replacing those values. Then by replacing those, now I'm making here, this implies first thing ax into here this one and this one, and I have to multiply a 0 into hz, 0 minus this one into this one, 0, next minus ay into this one, dou by dou x into hz, dou by dou x into hz, minus 0 into 0, 0, plus az into the third term, this one here, this one into this one, that is dou by dou x into hy minus this one into this one, 0 into 0, 0, equal to the same term, the same value will be the flux here, epsilon naught into dou ey by dou t into ay plus dou ez by dou t into az. Now I am simplifying here, this value will becomes 0. Next here the rest of the term is minus ay into dou hz by dou x minus 0 plus az into this one dou hy by dou x, dou plus az into dou hy by dou x equal to epsilon naught into dou ey by dou t into ay plus dou ez by dou t into az. Now compare ay terms on both sides. Compare ay terms on both sides. Here ay term is this one and here this one. So minus ay into dou hz by dou x, this one, equal to epsilon naught into dou ey by dou t into ay. Then by cancelling here ay, I am getting here dou hz by dou x equal to minus epsilon naught into dou ey by dou t, dou ey by dou t. Now I am assuming it is equation number 5. 4 equations are over and it is the 5. Now compare az terms. Now comparing az terms, here it is the az term and it is the az term. So az into dou hy by dou x equal to epsilon naught into dou ez by dou t, dou ez by dou t into az. Then with the both sides dou hy by dou x equal to epsilon naught into dou ez by dou t. It is equation number 6. Equation number 6, 5 and 6. Now consider equation 5. Consider equation 5. This is the fifth equation. That is dou hz by dou x equal to minus epsilon naught into dou ey by dou t. Here from uniform plane views, we have ey equal to function of x minus v naught t. Now we need here dou ey by dou t. That means we have to perform differentiation with respect to t. So dou ey by dou t performing with respect to t equal to, here the value is will become f dash of x minus v naught to t into minus v naught, because we are performing with respect to t. So the multiplicand of t is v naught. So then with this it will become minus v naught into f dash of x minus v naught t. That is the value of dou ey by dou t. Dou ey by dou t. Now substitute this value in equation 5, in this equation, or else here we have to substitute. Then by substituting this value here, then dou hz by dou x equal to minus epsilon naught already existed there. The value of dou ey by dou t is this one. By substituting here, minus v naught into f dash of x minus v naught t. Now here minus plus epsilon naught v naught into f dash of x minus v naught t. That is dou hz by dou x dou hz by dou x value. Now I'm making here inverse partial differentiation, here dou term and term. By making inverse, hz equal to, already epsilon naught is here, v naught is here, f dash. By making inverse, it will become f of x minus v naught t. We have already previously assumed that the value of e of x, already assumed here, the value of e of x, ey of x is f of x minus v naught t. Ey of x equal to f of x minus v naught t. This already assumed in our previous steps. Now this value can be replaced as ey. Then hz equal to epsilon naught v naught into ey. And then here we know that v naught equal to, v naught value can be written as 1 by square root of mu naught into epsilon naught. Just substitute this value here, then it will become hz equal to epsilon naught into 1 by square root of mu naught into epsilon naught into ey. Here already epsilon naught, here root epsilon naught. In this, root epsilon naught will be cancelled. Then hz is equal to square root of epsilon naught by mu naught into EY. Then finally EY by HZ equal to square root of mu naught by epsilon naught. It is the relation between E and H. E and H. At the same time, from equation 6 also we had to evaluate the same process. From equation 6 also we had to derive the same process. Now I am considering equation 6. Here the equation 6 is from equation 6 we have here dou hy by dou x equal to equation 6 we have dou hy by dou x equal to epsilon naught into dou ez by dou t. Look at here, equation 6. From equation 6 we have dou hy by dou x equal to epsilon naught into dou ez by. That's what I considered here. Now the same process I had to repeat here. The same process I had to repeat once again. Consider Ez equal to f of x minus v naught t. X minus v naught t. That is Ez. Then with this we need here dou Ez by dou t. So perform here partial differentiation. Dou Ez by dou t equal to fz of x minus v naught to t minus v naught. Then now substitute this value here. Here we have to substitute. This value has to be substituted here. Then dou hy by dou x equal to epsilon naught into f dash of x minus v naught to t minus v naught. With this we're getting minus v naught epsilon naught f dash of x minus v naught to t, that is dou hy by dou x. Dou hy by dou x. Now I'm making here again inverse partial differentiation. Then dou hy by dou x will become hy equal to minus v naught epsilon naught. Here f dash will becomes f of x minus v naught t. And already we have assumed here Ez equal to f of x minus v naught t in this case. So I'm replacing here Ez, that equal to minus v naught epsilon naught into Ez. Now here again I am substituting v naught equal to 1 by square root of mu naught epsilon naught. By substituting this value in this, hy equal to 1 by square root of mu naught epsilon naught into Ez. Here epsilon naught, root epsilon naught will get cancelled. Then hy equal to square root of epsilon naught by mu naught into Ez. Then finally we're getting here Ez by hy equal to square root of mu naught by epsilon naught. It is also the relation between E bar and H bar.